Okay, so today what we're going to be doing is we're going to be going over the basic log properties that we learned yesterday and how to apply them into other problems that we've seen. Okay, so in this first problem, it's asking us to evaluate the statement. Okay, so when we look at this, we can see that we have this logarithm. So yesterday we talked about what a logarithm means. So this logarithm, log base 2 of 8, what is that saying? That is basically saying to what power of 2, like what power do we put on 2 to make 8? So if you think about it, if I rewrite it just right out here and change it to its exponential form, so this to that power equals that. 2 to the y power equals 8. 2 to what power gives me 8? So this is 3 plus 5 times, and evaluate the same thing. Again, log base 2 of 1/2 equals y. So 2 to the y power equals 1/2. Well, what power do you take 2 to get 1/2? That's the negative 1 power. So basically this is 3, this is negative 1, so 3 times 3 is 9. And 5 times negative 1, so this is 9 minus 5. And 9 minus 5 is 4. So this is 4. Okay, so basically we're just using those log properties that we talked about yesterday to evaluate these new logs that we have sitting here right now. Okay, so again, same thing here. This is going to be 2. We're going to evaluate this log. This says 3 to what power gives me 27? Well, 3 to the third power gives me 27. Plus 4, and here 3 to what power gives me 1/3? And just like the last problem, that's negative 1. So this is 6 minus 4. Oop, why did I put that 1 there? 6 minus 4, and 6 minus 4 is 2. So this is 2. Okay, so we're going to start using these log properties and how to evaluate them and how to use some of the identities so that we can solve equations a little bit easier. Okay, so let's look at this one. It says to solve for x, so we got to get x by itself. Okay, well, when we solve for x, we're trying to isolate the x. So before I get started, I'm going to add 1 to both sides. Okay, so I'm going to get 2 log base 5 4x equals 12. And then I want to get rid of this 2, so I divide both sides by 2, and I get the log base 5 of 4x equals 6. Now I'm going to evaluate this just like we did in the last one. I'm going to say, well, change it to its exponential form by using the circle method. So 5 to the 6th power equals 4x. So rewriting this, 5 to the 6th power equals 4x. And 5 to the 6th power, that's a really big number. That's 15,625 equals 4x. Divide both by 4 to get x by itself. So x is 15,625 over 4. Okay, so all we did was basically get this logarithm by itself on one side, change it to its exponential form, and then solve for x. Okay, so just using these properties. Okay, we're going to work this one the same way. So we've got to get x by itself. So we're going to add 3 to both sides. So we get 6 ln of x plus 2 equals 24. Divide both by 6, which gives me the natural log of x plus 2 equals 4. And then, now that we've got our log by itself, we're going to switch it to its exponential form. Now remember, natural log of x is the same thing as log base e of x. So again, this is the circle method. So when I change it to its exponential, it's e to the 4th power equals x plus 2. And since we're trying to get x by itself, we subtract 2 from both sides. Now e to the 4th power is a number. We just have to plug it into the calculator, so I'm going to leave it like this. And that is the actual value. So basically, I'm using these log properties to actually simplify my equations so that I can finish and work them out. Okay? But you got to know how to change it to its exponential or how to evaluate a log before we can do that.